So
Are we starting right now?
share the screen. I'm audible. You?
Yeah, you're audible.
Yeah.
Mm-hmm.
Because I cannot hear your voice. That's the reason.
Yeah.
Okay.
Hello. Yeah, you can hear me now? Hello. Hello.
Okay. So that day, we were on the edge of ending the chapter.
Mm-hmm.
Shall we'll start with unit 4 today.
Mm-hmm.
Okay. So uh, we were remaining with, I think, data ethics. Last topic of unit 3. Unit 3. The last topic was data ethics. What are the ethical values that are related to the data that we need to keep in mind before we do some things with our data? So, what the data ethics? Am I clearly audible? Yeah, I cannot hear your voice.
Yeah.
What's the reason? I'm not understanding that. There's some glitch, I think.
Mm-hmm.
Okay, no problem. You can hear me, then just give me in the chat box. Yes,
Yeah, okay.
am I clearly audible? So just type in the chat box. Chat box. Yes,
Yes.
I can't hear your voice, right? That's the reason. If you can hear me clearly, just type yes so that I can continue teaching you. Okay, okay, okay. Thank you. So what are the data ethics? There are some potential experiments that are clearly unethical. In other cases, the boundary between ethical and unethical isn't as clear. Isn't as
Yeah.
clear. Ethical isn't as clear. Decide if you think each of the following studies is ethical or unethical. Means what? You have to distribute the given studies in two parts, whether it is ethical to do it or not ethical. So first of all, what we'll do, there are two parts in a data handling. Data handling. Data handling. Two parts are there. One is ethical and another one is unethical. This half part we have seen in the previous lecture. The things that we have seen before here, it was that whether it is what you'll say challenging or the challenges while facing, whether it is appropriate or inappropriate. Likewise, when you are measuring the things that lung cancer is caused by smoking, so you cannot offer cigarettes to the sample or the what you'll say experimental units or the subjects to what you'll say to have cigarettes and have it and see whether they get a lung cancer or not. This is very, what you'll say, unethical thing, which is not convincing. So, a promising new drug has been developed for treating cancer in humans. Before giving the drug to the subject, researchers want to administer the drug to animals to see if there are any potential serious side effects. So, see whether it is ethical or unethical when we are considering animal life. So, it will come into unethical. Animal life. Animal life. So it will be very unethical that for caution we put the life of animals in danger. Yes or no? Yes. So, are companies discriminating among some individuals in the hiring process? To find out, researchers prepare several equivalent resumes for fictitious job applicants with the only difference between the gender of the applicant. They send the fake resumes to the companies advertising positions and keep track on the number of males and females who are contacted for the interviews. Will people try to stop someone from driving drunk? A television news program has an actor to play a drunk driver and uses a hidden camera to record the behavior of the individual who encounter the driver. So the most complex issue of data ethics arises when we collect data from people. So the first thing, when we are generally correcting when when we are generally collecting data from common people, then data ethics come into picture. Then data ethics comes into picture. Okay, comes into picture. So here are some basic standards of data ethics that must be obeyed by all studies that gather data from the human subjects, both observational studies and experiments. The law requires that studies carried out or funded by federal government obey these principles. So when you are doing any project related to AP statistics or elsewise in your life, relate in statistics or any field or any research that you are doing, so there are some of the ethics and rules that you must be following while collecting the data. Okay, but neither the law nor the consensus of experts is completely clear about the details of their application. That's the thing. So you should be very clear to your thing that you are collecting. So what is the this is an important topic but is not required for every statistics exam. Okay, so basic data ethics. So this is not an exam point of view, but you should know what are the data ethics. So all planned studies must be reviewed in advance by an institutional review board charged with protecting the safety and well-being of the subjects. So means what? Prior examining the prior examination by an institution. We can make point by an institution of what you have to examine it, how and how well you are going to perform and how well you have planned the things. All individuals who are the subjects in a study must give their informed consent before data are collected. So all individual must be ready. All
Mm-hmm.
individual or subjects, you can say, must be ready by giving their consent.
Yep.
Okay, that's the thing.
Mm-hmm.
So all individual data must be kept confidential. No, no
Uh-huh.
leak of data about the subject must happen. Means the privacy of a subject or an individual is the highest priority. Is the highest priority. Means because the data that he's sharing with us may be confidential and he may be having some issues with it, so it must be only with the researcher. Only statistical summaries for groups of subjects be made public. So you can only what you can we can only publicly publicly share the output of a specific study without showcasing showcasing the individuals, the subjects involved. Means what? Which subjects were examined? Subjects involved. That's the thing. Is it okay? Okay. So I cannot hear your voice now
Yeah.
also. Not a
Yeah.
big problem, by the way. Okay. So what I'll do, I'll keep it here. come to know when you are speaking. So that's the thing. Is it okay? That's all clear. So confidently here, there are the institutional review boards. The purpose of the institutional review board is not to decide whether a proposed study will produce valuable information or if it's statistically sound. Means they will guide you whether you are collecting the right data for the study that you are going to conduct, or the method that you are using is right or not. So that's the thing. So informed consent, so both words in the phrase informed consent are important, and both are can be controversial. Subjects must be informed in advance about the nature of a study and any risk of the harm it may bring. So if you are giving some study or some medicine to an individual, either it may be a placebo effect or something, but you should be prior informed by a handwritten signatures of the subjects that any harm or risk that may happen is not in our, what you'll say, in our way. It will be on their side. So if they are ready by taking any risk and harm, so they can participate in it. In this case of question, a physical harm is not possible, but a survey or sensitive issues could result in emotional harm. So generally when you do studies, so you cannot give a subject to smoke cigarettes, but so therefore physical harm is not possible, but during an experiment some emotional harm may possible. So therefore consent is very important, and confidentiality, I think it is the most and the highest priority that must be given to our statistical study. So that's the thing. Alhamdulillah, we have finished with our chapter 4, by the way. So that's good
Mm-hmm.
thing. We'll be discussing problem inshallah in the next week of chapter for these problems about these things. Today we'll just start with our unit 4, I think. Unit 4 or chapter 5. I don't know. Wait, is it unit 3 only? We'll see. This is a whole exercise, good exercise. We'll discuss this exercise, inshallah. I have planned it to discuss it with you. So there is a practice test, cumulative AP, practice test 1, based on the 4 chapters that we have completed. Have you given Zaid? Just write in the chat box. I have forwarded the second, what you'll say, second examination, second test based on chapter 2 to your mother. So have you given the test on Saturday? Yes, I have forwarded it on Saturday. So have you given the test? No. So when you're planning to give it? This weekend? Okay. So give it soon. So I'll evaluate and forward it to you as soon as possible. The next thing is we'll start with our next chapter. Okay.
Mm-hmm.
You can give this test also. It will be very interesting for us. I'll evaluate this test also. Okay. So this will be a test will be as a homework. Okay. Then it's unit 4. Probability, random variables, and probabilities. So first of all, when you are coming this thing, take this on our screen. See what we are going to explore in unit 4. See, probability distribution. This is the most important thing that we are going to learn. Probability distribution. But for probability distributions, we need to understand what is the concept of probability, because in statistics, probability has 99%, what you'll say, share in statistics. 99% share of probability of statistics, 99% share of probability statistics has 99%, because in every calculation and sums probability comes into the picture. So first of all, you need to, for understanding probability distribution, you need to understand what is probability. So one part of it we have done it. What is probability? So chapter 5 in unit 4, by the way, chapter 5, it starts with the term probability. So the introduction, I think I've given you in our previous sum, that the favorable
Mm-hmm.
outcoming the chance of favorable outcoming of individual an individual may be termed as probability. I've just given a layman definition. Termed as probability means what? You have to measure something. You have to measure that there are three balls, red, blue, and green. So what's the probability of red? So there is favorable chances are, that's one, and the total number is three. So what's the probability? 1/3. That's the probability. That the chance of the favorable outcoming of an individual means here favorable is our red. Its outcoming is one in the whole sample space is termed as probability when you divide it by the whole sample space. That's the thing. Is it clear, Zaid?
Mm-hmm.
Okay. So chapter 5, it's probability. So what we are going to learn in this chapter, one is randomness, then the second one is probability, and the third one is simulation. So in 5.2 probability rules, what are the specific rules? And then main important probability are the different types of probability, that is conditional probability and independence. Conditional probability and independence. I'll just the chat window here. Then there will be a wrap up. So introduction, chance is all around us. That is the thing. I'm telling you, chance. When probability comes, whenever probability is mentioned, when our probability is mentioned, the word that comes in our mind is chance. So everything that is around us is based on our chance, what you'll say, based on chance, how much chance he has in a specific room. So you and your friend play rock paper scissors to determine who gets the last slice of pizza. So a coin toss decide which team gets to receive the ball first in a football game. Many adults regularly play the lottery, so she is giving, what you'll say, different conditions, so where chance comes into picture. There are a lot of things where chance comes into picture. So first, in a football game, many adults regularly play the lottery, hoping to win a big jackpot with a few lucky numbers. So there are millions of numbers in that lottery, and there are a few prizes, maybe 5 or 10, which are in, what you say, millions. So what they do, they test their chances of success. The adults that play lottery, they chance their chances of success. Others head to casinos or racetracks, means for that horse race and all, hoping that some combination of luck and skill will pay off. People young and
Mm-hmm.
old play games of chance involving cards or dice or spinners. The trials that children inherit, hair and eye color, blood type and handness, dimples, whether they can roll their tongues, are determined by chance involved in which genes their parents pass along. The mathematics of chance behavior is called probability. So here he has given a the what he has said, the mathematics of chance behavior. The mathematics means the calculation. The mathematics, I'll explain this definition. The mathematics of chance behavior is known as probability. Probability. Okay. So what is the thing that the mathematics of chance behavior means? The calculation. Mathematics is referred to as calculation. So what is the calculation here? It is the calculation of number of chances an individual is having coming in a sample space. So that is termed as
Mm-hmm.
probability. Is it clear, Zaid?
Yeah.
Yeah. Are you getting it? What I'm
Yeah.
explaining about the probability?
Yeah. Mm-hmm.
Just type
Yeah.
yes.
Yeah.
It's going on well. Is it going on well, Zaid? Okay. Yes. Okay. Okay. Okay, dear buddy. Okay. So probability is the topic of this chapter. Here is an activity that gives you some idea of what lies ahead. So here he has given an activity. By the way, we have done some sums related to the probability in our previous chapters also. So come on, read this. Come on, it's your task. Read this. In this activity, you and your classmate will use simulation to test whether a company's claims is believable. As a special promotion for its 20 ounce bottles of soda, a soft drink company printed a message on the inside of each bottle cap. Some of the caps said, "Please try again," while others said, "You are a winner." The company advertised the promotion with the slogan, "One in six wins a prize." The prize is a free 20-ounce bottle of soda. So Grayson statistics class wonders if the company's claims hold true for the bottle. Means what? What they can do, Zaid? That they can make a fake advertisement that for suppose there is a I've taken 6 bottles of their soda. Okay, so on 4, 5, and 6. No one has please try again. All have please try again. PTA or PT. All the three have PT. So he's making us a fool that he has not given a single cap in a bunch of six that is having you are a winner. You are a winner. So when there is a no cap with this caption, so what he is doing is just making a fake advertisement of the things. So we need to test whether it is the case or not. The bottle have you are the winners what you'll say context or not. Okay, so what does Grayson statistics class wonder? The company's claims holds true for the bottles at a nearby convenience store. So here in a convenience store means we are doing a convenience sampling. While choosing a store, we have choose by our convenience. See the minute thing that you have to note down. To find out, all 30 students in the class go to the store and each student buys one 20-ounce bottle of the soda. Two of them get caps that say you are a winner. Thus, this result gives convincing evidence that the company's 1 in 6 claim is inaccurate. So, first of all, what is the company's claim? Company claim. You need to understand. Company claims that 1 in 6 bottle contains the cap of winner. So what is the probability of getting a cap of winner? So by the claim, by the claim we are telling. So it is 1 from 6. So it is around 0.1 666 0.166. That's the probability 1 by 6. So now what they have done, we conducted a what you will say experiment. So we have conducted the Grayson statistical lab have conducted an experiment. There were 30 students who buyed the bottle. 30 students buyed the bottle. Okay, bottle. Then how much it came? How much were winner? By the way, here 20 ounces. You are a winner. Two of them get the cap. That say you are the winner. So two of them two of them were the winner. Were the winner. So what's the probability that they became the winner? So it was probability equals to what we have obtained. Two, they have got a winner and the total were 30. So 2 upon 30, it is about 1 upon 15. And 1 upon 6 and 1 upon 15. Are they equal? No, they are not equal. So the claim that was, what does it tell? 15 bottles in a bunch of 15, in a bunch of 15, one cap contains winner. Contains winner. But what is his claim? That 1 in 6. So the claim is inaccurate. What you can say from the study? Claim of the company is inaccurate. Is inaccurate. Yes or no? Yeah, that's the thing. So is inaccurate. So now let's assume that the company is telling the truth. We are assuming, and that every 20-ounce bottle of soda it fills has a 1 in 6 chances of getting a cap that says you are a winner. We can model the status of an individual bottle with a six-sided dice. So what you can do, model the status of an individual bottle. So means what you are taking bottles and throwing a dice. Let 1 through 5 represents please try again, and the 6 represents you are a winner. So what they have done, they have taken 6 bottles, by the way. 6 bottles, by the way. So 1, 2, 3, 4, 5, and 6. Okay, 6 bottles, and they have taken a dice. They have taken a dice numbering from 1 to 6, but from in a dice 1 to 5, will when 1 will come means, when 1 to 5 the numbers will come means please try again, and when 6 will come it will have, you are a winner, you are winner. So what he is doing, see, he's playing on chances. What chances are there? So roll your die 30 times to imitate the process of the students in Grayson's statistics class buying this soda. How many of them won a prize? So that's the thing. There are 30 students. You need to roll the die 30 times. For suppose you have rolled the die first time, first for the first time, first student has got 5. So it will get please try again. Then for the second student, it gets 2. So it will represent please try again. For the third, you will do it this like first 10 student, it came out to be 6. So it will be you are a winner. You are a winner. So in the 25th also it will happen that, in the 12th also it will happen 6. So you are a winner. Okay, in the 25th also 6, you are a winner. So that's the thing you need to do. For until 30 you have to go. For example 30 it is called 2. So please try again. That's the thing. You have to play on the probability, means the game of chances. Okay. So your teacher will draw and label axis for a class dot plot. Plot on the graph the number of prize winners you got in step 1. So means you have to plot a dot plot. For example, here 1, 2, 3, 4, likewise till 30. So for example, the third student got a prize, so I'll measure it here. The 20th student, the 30th student, likewise, I'll measure a put a dot plot representing how many students got a dot plot. So repeat steps 1 and 2 if needed to get a total of at least 40 trials of simulation for your class. How many trials is telling? Zay? 40 trials means 40 into 30. How many times you have to roll the die? 40, 40 trials of every 30
Mm-hmm.
students. So 0, 0, and let's see how much it
Yeah.
is. 1200 times you have
Yeah.
to roll the die. That's the thing. So discuss the results,
Mm-hmm.
and in every 30 means there will be 40 dot plots. 1, 2, then there will be 40 dot plots if you are doing 40 trials. Discuss the results with your classmate. What percentage of the time did the simulation yield two or fewer prize? To yield two or fewer.
Uh,
Now we are testing that from this, in this dot plot, means on this dot plot how many dots were 2 or less than 2, means that 2 people won the prize or less than 2 people won the prize. How many of the dot plots were like that? So in representing a dot plot and finding from it, it is simple. So field winners in a class of 30 students, that's by chance. Does it seem plausible that the company is telling the truth but the class just got unlucky? Or is there convincing evidence that 1 in 6 claim is wrong? Explain your reasoning. So you have to write all the things by explaining the reasoning, that how will be the reasoning that there is, when you are doing with a dice. See, when you are doing with a dice, so there is a probability. What has the, for example, this is a die. Now, for example, this is a die. So there are 6 faces, for example, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So what is the probability of 6 in the whole die? So 6 is one time, and the total number are 6. So what is the probability? 1 by 6. The probability of 6 on the die is 1 by 6. Therefore, when you are doing it by a die, when you are doing it by a die, doing it by a die, so there is a high chance, there is a high chance, high chance that 1 in 6 becomes a winner, becomes a winner, because I'm writing the reason, because each number each number on the die, on the die has a chance of 1 in 6. How 1 in 6? See, I've told you. For example, 1, 2, 3, 4, 5, 6. What is the probability of coming 1? So it is 1 by 6. What is the probability of coming 2? It is 1 by 6. What is the probability of 3? 1 by 6. So on. 6 is also 1 by 6. So all have 1 by 6. So coming on 6, the one winner in 6, the chances is very. Is it clear, Zain? That's right. Yes. If it is clear. Right. Yes. If it's clear. Are you there? I told you. Oh yeah. Thank you. Okay.
Yes. Yes.
I
Mhm.
cannot hear your voice, by the way.
Yes, you
Anything I
can.
can see. Just a minute. What I'll do.
Mm-hmm.
Stop sharing. Or else, it will just we have wasted a lot of time. I was setting this issue only as Zoom was glitching. There is some. I think there is some system glitch in Zoom. By the way, so that's the reason I was fixing that only. But I landed in. I landed with not solving the issue. So I've started the class like that only. Come on, we'll fix the issue by tomorrow. And very really sorry for yesterday that it slipped from my mind as I slept very late at night as I have papers for checking of my Indian school year. I had papers 190 papers of checking and I have checked that papers and just slept at 2 o'clock and I have to take a class at 5 here. There's in India 6 and I've slept at 3 by doing the Sehri. So it slipped from my mind to message you that there won't be a class that day, means yesterday. So I apologize for that, that I didn't mention and inform you prior to the meeting and you were waiting. Really sorry for that. Okay.
That's
Okay.
all
So
right.
now coming on to the next topic, that's section 5.1. That's randomness, probability, and simulation. Randomness means what? You have seen when we were designing an experiment, we use the term very much. It's random sampling, random choosing, random assignment, random, what you'll say, all the things that we were doing wasn't random. Why random? Because randomness, why random? That's the question. Why every time random? Randomness. So the topic is randomness. So the question comes, why
Mm-hmm.
random? Why random?
Hmm.
That's the question. So the answer is the random what you will say randomness provides equal chance of success, equal chances of to ed- success to every individual, to every subject or individual, to every individual or subject. That's the reason randomness is preferred when that means when you are selecting anything, choosing anything, just what is preferred randomness, because every trial should get a good chance and equal chance. So that's the thing. So we'll imagine tossing a coin 10 times. How likely are you to get a run of 3 or more consecutive heads? An airline knows that a certain percent of customers who purchase ticket will not show up for a flight. If the airline overbooks a particular flight, what are the chances that they'll have enough seats for the passengers who show up? A couple plans to have children until they have at least one boy or one girl. How many children should they expect to have? To answer these questions, you need have a better understanding of how random behavior operates. That's the thing. Means what? For example, see this what he is telling. For example, I'll toss a coin. I'll give you one example of randomness, how randomness comes into picture. Example, I'll toss a coin. I'll toss a coin until one head appears. One head appears. So first coin I have topped, it came to be tail, 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 tail. So I'll toss it, toss it, toss it, toss it, toss it till head appears. When the head appears, so I'll stop. So this I have explained you. So how many times I'll toss the coin till the head appears? So for example, first is tail. second is also tail. It may happen that in the first three trial it may come directly head. Why? Because head has the probability 1 by 2 when one coin is tossed. Yes or no? That's the thing of randomness. So you need to work with probability. What is the probability of that specific outcome to come? By the way, so that's the thing you need to look in when you are considering randomness. So the idea of probability in football, a coin toss helps determine which team get the ball first. Why do the rules of football require a coin toss? Because tossing a coin seems a fair way to decide. So that's the thing. See, when you are distributing between tails and heads, heads and tails or tails and head, so both of them have a probability of coming half. Means the outcome when you toss a coin, both have the probability that the outcome will come one time tail and one time head. It may happen that it may have tail, 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 then head, or head, 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 directly head and head and tail. It may happen, but they have equal probabilities. Therefore, this way of deciding is called fair way toss, fair way toss. When both the outcomes are having the equal probability of coming, then there is a fair way of toss. What does that mean exactly? The following activity should help shed some light on this equation. What is probability? So that's the thing. So what do I think? Come on, we'll do this example and then stop. So if you toss a fair coin, what's the probability that it shows heads? It's half or 0.5. Correct. I've told you how to measure the probability. See, again, I'll first of all give you the formula for probability. Probability equals to number of favorable outcomes. Number of favorable outcomes. Favorable means depending on our condition, what we want. Favorable outcomes upon total number of outcomes. Total number of outcomes. That's the formula. So, for example, total number of outcomes, tossing a coin. Tossing a coin. What are the total possible outcomes of tossing a coin? Heads and tails, correct? And I want
Mhm.
getting a head. Getting a head. So, what's the favorable outcome? That's only head, correct? So, what is the probability?
Mhm.
Probability of getting head. So it is favorable is 1 and the total is 2. So it's 1 by 2, which is around 0.5. Got it? Yes, that's the
Mhm.
way how you calculate the probability, by the way. Okay. So 0.5. But what does probability half really mean? In this activity, you will investigate by flipping a coin several times. What does probability exactly mean? That it is having a probability half. Means what? When you toss a coin, for example, two times, what does this half means? Question is what does this 0.5 probability means? So I'll explain you that if we are tossing a coin, if we are tossing, if we are tossing a coin two times, there is a high chance, there is a high chance of getting tail one time and head on the other try, on the other trial. That's the thing. Means when you are tossing, for example, I've tossed the first time. So if it is coming tail, so there is a high chance that on the second chance it will come head because both have half probability, 0.5. Or for example, on the first trial it may come head. So on the second trial it may come tail. So this output is the highest, have the highest chances. It may happen that on the first toss it came tail and on the second also it came come tail. In the first it came head, but and on the second also it came head. It has chances this also, but your chances are low. Chances are very low, and your chances are very high. This type of output, chances are very high. Okay, so we'll read it what he has given there. So toss your coin once, record whether you get heads or tails. Toss your coin a second time, record whether you get heads or tails. What proportion of the first two tosses is heads? what proportion of the first two tosses is heads. Means what? You have to toss a coin two times. For example, that on we consider this output. On the first two tosses, both are tails. So what is the proportion of head? So it is 0 upon 2. Yes or no? So what is the proportion? It is 0. Correct? Because when we are okay, when we are considering, for example, that this is the output. This one. Pen is not working now. What the this Zoom is having glitches or some update is going on in the back end. So in this way, it will have a probability 0. In this here, it will have a probability 2 upon 2. It will have 1. And here you know what is the proportion. Here it will be 1 by 2, 1, 1 by 2. And here also it will be, in this case also it will be 1 by 2, the proportion of head and tail. So there is a all the things of chances that you can see. Okay. So toss your coin 8 more times so that you have 10 tosses in all. Record whether you get heads or tails on each toss. You can do this experiment side at your home while tossing a coin. You will see that it will have 1 by 2 probability on all the times. On all the times it will have 1. Means you are tossing the coin 10 times. It will be very near to 5. The outcome of heads in 10 tosses, it will be very near to 5, or it may happen, it may have 6 or 7, near to 5, in the range of 3 to 7. You can see. So calculate the overall proportion of heads after each toss and record the values, these values in the bottom row of the table. For instance, suppose you get tails on the first toss and the heads on the second toss. Then your overall proportion of heads would be 0 by 1, means you have to make a table like the way he has given. Means 0 toss 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So for on the first toss, you get tails. So what's the proportion of head? Proportion head didn't come, so it is 0 upon 1. So it is 0. On the first toss, you get it will be 1. Na? Sorry, this will not be in consideration. It will start from 1. You get tail, so it will be 0 by 1. On the second toss, also you get tail, so it will be 0 by 1. On the third toss, for suppose you will get head, so it will be 1 by 1, that's 1. On the fourth toss also you get head, so it will be 1 by 1, that's 1. So when you will add all these things, so it is 0 plus 0 plus 1 plus 1 divided by the total. How many toss you have done? 4. So it is 2 upon 4. See, the probability is coming up. You do this at your home side and perform it and tell me the answer tomorrow, that what it has come. See here, he has given the graph of heads and tails toss, this number of tosses and probability. Here you can do it. Repeat this process more several times. What do you notice? See the probability. Probability. Tails, it's 0.6, and heads, it is coming around 0.4. So that's the thing, it varies depending on the chances, but it is very much close to 0.5. Is it clear? Yes or no? Okay.
That's
What
clear.
if you toss the coin 100 times? Reset the applet and have it to do 100 tosses. Is the proportion of heads exactly equal to 0.5 or close to 0.5? It will be not exactly, but close to very much to 0.5. Keep on repeating, keep on tossing without hitting reset. What happens? The proportion of heads as a class, and we have seen the more the sample space, the larger the sample space, the more accurate is the result. So when you will increase from 10 tosses to 100 tosses, it will be very close to 0.5, or it may happen that it is exactly 0.5. Are you getting it, right? What I'm trying to explain here, chances. As a class, discuss what following statement means. If you toss a fair coin, the probability of head is 0.5. If you toss a coin, it can land head or tail. If you toss a thumbtack, it can land with the point sticking up with the point down. That's the thing. If you have removed the, what you say, fairness from the coin, it may happen that it is not fair enough to be what you'll say measured. So figure 5.1 shows some results from the preceding activity. See here, number of tosses is 10. You can see, I have told you, there will be a large variability in the data, but when you have decreased the increase the number of tosses, so it is very near to 0.5. Yes or no? That's the thing. The figure is showing
Yeah.
us depending on the tosses. So when we watch coin tosses or the result of random sampling, here we are doing random sampling of tosses and random assignment closely, a remarkable fact emerges. Random process is unpredictable in short run, but has a I'll make it a point on our board. It's very important. That's the reason I'm telling you why randomness is considered everywhere in statistics and probability. So what it is, that a random process is unpredictable in short run, means in short run, in short run, results may have variability. We can write in statistical terms, may have great variability or large variability also, you can say large variability. But in long run or large sample space, large sample space, large sample space, the output is predictable. This is the basis for the idea of probability. So this was the ground reality, ground reality of probability. That's the thing. That where probability comes into picture. When you have a large sample space, and when you are considering very large things, so that's randomness where it comes into picture. So there's now random process and probability. We'll just read the definition. A random process generate outcomes that are determined by purely by chance. So what is a random process? When we are calculating basis on the chance process, so then random process comes into picture. The probability of any outcome of a random process is a number between 0 and 1. Means probability means any random chances experiment, means any random chance experiment, that's known as probability is always between, it is always less than or equal to 1 or greater than or equal to 0. It will be always between 0 to 1. We write usually like this: probability is belongs to closed interval 0 to closed interval 1. Closed interval means this is closed, box interval means 0 is included. It may happen that some event has a probability 0 and some event have a probability 1. Is it clear? Okay.
Mhm.
So that's the task. Is it clear, Zaid?
Yeah.
Yes or no? Okay.
Yeah.
So shall we stop here? We'll start the
Mm-hmm.
next topic tomorrow, inshallah. Okay.
Yeah. Okay.
Just type yes. So we'll stop sharing. Just type yes. So I'll stop sharing. Okay. Shall we end here? Okay.
Yeah.
Assalamu alaikum.
Walaikum salam.
Okay. Type yes. If there are some difficulty, you can type here, by the way. Okay. We'll leave. Assalamu alaikum wa rahmatullah. Allah Hafiz. You take care.